Conference. As you can see, my name is Brian Adler, and I'm an architect in our services organization. And in that role, I end up talking to a lot of our customers, be they the small or the tall, right? Be they the small two guys in the garage with a credit card and a dream, as my old boss used to say, all the way up to the enterprises. And in that role, I've helped a lot of folks bring their applications, either legacy and or new applications onto the cloud. And basically figuring out how the best fit for those architectures, if you will, as far as getting that application up and running. Once services is sort of done with them, right, folks kind of go off and do their own thing. If they have problems, they hit up our support department. And we don't necessarily know what happens to those deployments after that, right? So where I'm going with this is that sort of the genesis of this talk is that Josh Frazier, you've probably seen a few times now, who's our senior VP of Biz Dev and Sales, came to me and said, hey, Brian, we've got a couple big customers that we haven't really talked to in a while. They're off doing their own thing, and everything's humming along just fine, but we like to kind of show them that we can continually add value for them. So could you take a look at their deployments and just kind of take a look at their accounts and see what they're doing and find out where they're doing things right, maybe where they're doing things wrong. And the most interesting part is he said, find out where we might be able to save them some money, right? So when you have the head of sales telling you, find out ways for you guys to pay us less, I thought that was pretty interesting. So I jumped at the opportunity and took a look at a couple of these customer deployments, and they were a big hit. So I got asked to do more and more of them, and I used to manage a group of guys, and I told them, I said, don't get good at things you don't like. Not that I don't necessarily like doing this, but it's another full-time job in addition to my regular job. So I trained some of the folks in the CSE team, the Cloud Solutions Engineering team, like Ryan Geyer and his guys, who you may have seen do some of the presentations the last day or so. And then the thought came, hey, why don't we teach our customers how to do this for themselves as well? So the point of this talk is sort of to give you a run-through of what I do when I go ahead and I take a look at these deployments and try to find where we can optimize and or improve utilization and performance and things along those lines, okay? So first of all, why do they make sense? Well, over time, deployments tend to sprawl, right? We tend to have these deployments that grow organically over time. And I'm sure we've all been in this position, right? You have to address something really quickly and really, really urgently. And you go ahead and do it a way that kind of works, but maybe not the best way. And you always say, hey, I'll go back and address that later, right? And as we all know, rarely do you actually go back and address that later, right? So things kind of get a little spaghetti on you. Then the other thing is, hey, well, yeah, I want to readdress it, but it's working, right? It's not broken, so I don't want to fix it, so let's not touch it. So that's another reason that these things tend to grow and become a little unwieldy over time. And the last point I mentioned there is about squeaky wheels get the grease. Hopefully you folks are using the RightScale platform's monitoring and alerting capabilities, right? And as such, you're getting alerted when servers are having issues or you've lost, running out of EBS space on your volumes, things like that. Those are the squeaky wheels, right? Those are the ones that you're hearing about and you want to go ahead and address. But what happens if you're over-provisioned, right? Not a lot of our folks have alerts or monitoring set up if something's super underutilized, right? So as a result, it just keeps humming along, maybe costing you money when you could be using a different resource for that particular task that you may have, right? The whys and the whats. And before I get a little deeper into that, I'd actually kind of like to ask you guys, I know we have a lot of prospects here today as well. How many of you all are currently RightScale customers? Okay. So you're currently using the RightScale Dash. And of those folks, raise your hand, how many of you are not using not using AWS? Okay. So what we're going to talk about here is the majority of our customers to date have been on AWS. Now we definitely have huge influx in the other clouds as well. What I'm going to talk to you about here kind of has some AWS specifics in it, like things around EBS Snapshots and EIPs. So the concepts we're going to talk about are all accurate regardless of the cloud you're on, but the implementation details may be a little different depending on the particular environment that you're in. I'm also showing, as I mentioned, some snapshots of the RightScale Dash. For those of you who are familiar with it, this will look familiar. If not, it shouldn't be that foreign, and I'll kind of point out the parts that are interesting. Okay? Deployment checkups, or these deployment tune-ups, right? Why do we want to do this? Well, cost. We want to find a way to save money, right? Both from the resources that you're consuming, and then, altruistically, you don't have to pay RightScale as much, right? We'd rather have you, a longer-term customer, paying us less each month than paying us a lot for a shorter period of time, right? We're not selling you a used car we're never going to see you again. We'd like to see you every month. Performance, right? Let's find ways to optimize the performance of your applications that are running within the RightScale platform. And then just sort of general best practices, right? When things go bad at 4 in the morning, as Joe was talking about, you want to have some sort of recovery process in place. If you're following best practices, it's a lot easier than you have to do some sort of mad scramble and do some manual configurations and things like that. The what are we going to be looking at, right? Well, as I mentioned, cost optimization. Find areas where we can optimize costs and hopefully save you guys some money. Server utilization kind of ties in with cost optimization. That's a big part of it as well, but also trying to find a better way to use the servers and the resources that you have for the tasks and the applications that you're trying to run on them. We'll talk a little bit about HA and DR, high availability and disaster recovery. I have a later session this afternoon, I think it's at 1:30, where I delve into great detail on how to set up HA and DR environments if you're interested. This is more going to be what I look at when I look at a deployment to see if these are set up in an HA and or DR type configuration. Security, obviously you want to make sure that you don't have ports open to, for any purposes other than you absolutely need them. So we'll talk a little bit about security. And then again about best practices, just sort of making sure that you guys are following these best practices to allow you to improve your operational efficiencies and or automate anything you need to automate, right? First part I'm going to go through is the deployment checkup is cost optimization. So we'll talk a little bit about cost first. There are a lot of unused and unneeded resources. Joe Emerson was talking earlier today about the S3 version buckets, right, where he deleted it and he thought it went away and it really didn't, those kinds of things. I spent a lot of time looking at these things in customers' accounts, and I call it more of the dirty laundry concept, right? That if you have a pair of socks laying on the floor, you notice it, but it's not really a big deal. You just kind of kick it out of the way or whatever, right? It's only when it becomes a big mess like this that you're like, okay, I have to deal with this. Let me wash this stuff. Let me put it away. Let me do whatever it is I need. But with all the cloud providers' platforms, right, this is kind of, you have to go looking for it, right? All this dirty laundry is kind of hidden behind the closet door, and you don't see it every day. It's not in your face, so you kind of forget that it's there, right? This big mess is still there. It's just hidden behind this closet. So what I do is I open the closet, take a look around, and see what dirty laundry is in there and what we can get rid of, right? So the first one is EBS Volumes. And I realize the font here is probably incredibly small, and I apologize for that because you're going to have a common theme here. But the point is to show that in this particular instance, this is actually the services account that we run in every day. I'm going to show you both stuff in the services account that I'm comfortable showing you, and then I have some other things in some customer accounts with some redacted names so that the innocent or guilty, as you look, are not divulged. But in this case, we have 733 EBS volumes, and I've sorted them by the status column, right? And you see that a whole bunch of them are available, and some of them haven't been touched in years, right? 8 months and even years. So these are probably things that we can get rid of. We're paying for this, right? We're paying for this every month, and we probably don't need the vast majority of these, okay? So this is the first thing I always recommend to folks to look at is look at your EBS volumes. If you haven't had them attached in a very long time, you probably don't need them, right? That EBS volumes then leads into EBS Snapshots, obviously. And in this case, there's, you probably can't see, but over 3,500 EBS Snapshots in this particular account. And I've highlighted the volume size, right? We're paying for every single one of these snapshots, some of which are very, very old, years old in some cases, right? So do we really need these? Again, I take a look at these customer accounts and I document these and give them in a little sort of report format, if you will, the findings that I have. But a lot of times they'll say, hey, you guys have, I had one customer that had over 20,000 EBS snapshots, and most of them were over 3 years old. And they were like, wow, I had no idea that that was there. Again, this is that dirty laundry concept, right? It's hidden behind the closet door. They don't see it every day. It's not in their face. It's not prevalent, so they don't know to go looking for it. The next one, and this one isn't that costly, granted, okay? These are, pennies and stuff like that, but it does add up, and I kind of look at this, and that is the concept of EIPs. For those who are familiar with Amazon's Elastic IP, you pay for an EIP if it's not in use, all right? So if you're not currently using it, you are paying for it. If you are using it, you're not paying for it, right? So what I've highlighted there is the ones that are inactive, right? So they're inactive, we are paying for those EIPs, and we're not currently using them, right? Maybe you need them because it's something that you occasionally launch and you want to have access to those, and that's fine. The point is just take a look and make sure that these all make sense to you and that, yes, I really do need these, right? S3 objects. And this was a little harder to show, so I just kind of did a generic snapshot of the RightScale Dashboard. But as Joe was talking about, right, in his case, right, he had, probably, he didn't mention how much, but probably gigabytes, if not terabytes of stuff laying around in S3 that he really didn't need, right? It's really hard to get a good view of this, okay? There's not a lot of tools that allow you to kind of delve into these individual buckets and see what's in there. But the point being is that you're paying for this all the time, right? Amazon recently announced last week that they had crossed the 2 trillion mark as far as objects in S3, right? What I'm wondering is what percentage of those 2 trillion do people really need, right? And that's a bigger question, right? Amazon doesn't have a problem that there's 2 trillion. They're very happy about that. But you folks probably want to take a look and maybe you can get that number below 2 trillion for a little while. Storage, another area for cost optimization is storage. don't over-allocate initially if you can get around it, right? You can increase capacity later when you need it. If you say, hey, you know what? I've got this great new app coming out. I know that my database is going to grow to be a terabyte, so I'm going to get a 1 terabyte EBS volume. But right now I'm only at 50 gig, but I know I'm going to grow. Well, you're not paying for 50 gig, you're paying for 1 terabyte, right? So that's important to realize that you're paying for what you've allocated, not what you're using, okay? So if you have an application which can lend itself to maintenance mode or a little bit of downtime, we have the tools, and what I've highlighted there in the tiny little font is the do primary restore on the storage toolbox. And there's similar functionality on our database manager templates. And what that allows you to do is to take your EBS volume and basically grow it, right? You can say, hey, I've got this 100 gigabyte EBS volume. I need to get myself up to 500 gigabytes. Okay, let me go ahead and use this recipe to allow me to grow that volume, right? Allocate when you need it ahead of time. Allocate when you need it. Don't allocate too much ahead of time because you are paying for that storage, okay? Bandwidth. This is a little tricky. It's just sort of a thing to be aware of, right? Cross AZ, if you go from AZ1 to AZ2 or AZA to AZB, they always give them letter designations, you're paying for that, right? It's pretty cheap. It's currently a penny a gigabyte. It's usually noise in people's bills, but it is worth pointing out. We do recommend that, though, that you generally absorb that cost because from an HA perspective, you want to spread yourself across those multiple availability zones. You want to have that ability to have that high availability. This is sort of insurance, right? You're paying for something you hope you don't need, and a penny a gigabyte is probably a cost that you should be willing to or able to absorb. If you're going cross-region or cross-cloud, you're paying the sliding scale, right, of the bandwidth for the egress from that public cloud. And as such, that's probably necessary for your DR environment, and we'll talk a little bit about that in a minute and in more depth this afternoon. But we recommend that you compress that and or use a WAN optimizer. There's a lot of tools out there. One of our partners, someone mentioned it the other day, it's CloudOpt, and their product is called Cloud Optimizer, which is a WAN optimization tool, which can help you reduce the amount of data that you're sending across, right? So this is more just to be aware that this is what you're spending and try to find ways to either compress it or eliminate it if you can, all right? So the sort of, like I said, the cost optimization, that's sort of cleaning up the dirty laundry, right? Finding the stuff that the cruft that you don't need and trimming out the cruft. What we're going to talk about now is server utilization. And this is almost always where I find a lot of inefficiencies in folks' deployments, okay? This is the single place that I probably find the greatest amount of savings for customers is in the server utilization, right? So it's very important via load testing or however you want to do it to find the right sized instance for the task that you're trying to do, right? A lot of folks will just go ahead and throw a particular instance size at it and hey, it's working and great and that's all and well and good, right? But you really want to make sure that you're using the correct instance for the correct task. You don't want to be overutilized and you definitely don't want to be underutilized, right? You heard Joe and Torsten and a couple other folks talking about reserved instances as well. For those who are familiar with that concept on AWS, if you know that you're going to need this instance size and this AZ for an extended period of time, you can save a lot of money if you use reserved instances, okay? And our Plan for Cloud tool can help you with that. It can sort of do that cost forecasting for you, and you can play games with, hey, if I had 5 reserved instances, how much would it cost if I had 10, if I had none, that kind of thing. So what I try to show here is on this particular graph, right? Something weird happened at the end of week 1, the early part of week 2, right? I hope that these folks had alerts in place to be alerted to that fact, right? What we've got here is a server that's really thrashing under I/O weight, and hopefully they had an alert in place to be able to catch this, right? And eliminate or at least identify and fix this problem before it became a much, much bigger problem. So the point being here is that maybe there's an application problem, or maybe the load just got so big it's time to grow the instance size, right? So take a look at your server utilization. The other thing I mentioned to folks, and almost nobody takes advantage of this, and granted, a lot of applications don't necessarily lend itself to it, but is the concept of CPU affinity, right? For those of you that are Linux folks, there's task set and IRQ balance, which allow you to basically lock a particular process to a particular CPU, right? For these multi-core CPUs that you can get in AWS and Rackspace and all the other providers, you can get, some of them have just 1, others have up to 8, 16 virtual cores, right? So you've got all these CPUs, and generally everything defaults to CPU 0. So CPU 0 is getting hammered all the time, and the other CPUs are sitting around doing a whole lot of nothing, right? So we generally recommend, if you've got these multi-core CPUs, try to spread that load, if you will, across the CPUs, right? Like I said, not all apps lend themselves to this, but if you're running multiple processes on the same instance, try to take advantage of these types of tools, all right, and spread the load around the available processing power that you have. This is going to tie into load, which we'll take a look at in a second. I think the next slide's on memory. Lots of different options as far as instance sizes out there are concerned, right? They've got everything, at least in Amazon's world. Again, I apologize, it's kind of Amazon specific because the majority of the deployment reviews I've done have been in these environments. But everything from 613 megabytes, right, which is their 2 to the 30th as opposed to 10 to the 9th kind of thing, all the way up to 244 gigabytes. It's essentially a gigabyte, right? There's a huge array there. You should be able to find something that matches the needs of your particular application if you're a memory-hungry application. What I've shown here is folks were running on an M1 large, and there's 15 gig of gigabytes, if you will, of memory available here, and they're running at about 13, right? And that's great, right? And they probably have set MySQL, this was a database server, they've probably set MySQL to go ahead and consume that much, which is perfect, right? This is sort of ideal. You want to be running at 70, 80% of memory consumed, and hopefully not have too many spikes, okay? I talked a minute ago about load, and for those who are familiar with the load concept, it's a very good indicator of overall server utilization. The analogy that I've always been given is that it's sort of like a bridge, and you have cars going across the bridge. And if you're at 1.0 utilization per core, and we'll talk a little bit about that in a second, but if you're at 1.0 utilization per core, it means traffic is flowing perfectly. If you added any more traffic, you'd start to have backups, right? If you have a 4-core machine, 4.0 is sort of you are fully utilized, right? You can go up well above 1. We have folks that are running on M1 smalls which have 1 core, and they're running at a load of 5 and 6 and 7. What does that really mean? It means processes are waiting for the CPU, right? You have things that are waiting to get processed, okay? So what it makes sense to do is, again, use that CPU affinity, right? The folks in this case were on I forget the instance size, but it was a 4-core CPU. And I know you definitely can't read it because I barely can, but their average was less than 1. It was like 0.6, right? So they've got a 4-core CPU. They could be running at, and you don't want to be running at full throttle, right? 60, 70, 75% would be an ideal threshold to have. It gives you a little bit of room to grow. So they, in theory, should be running at 3, 3.5, and they're running at 0.62. They were not using CPU Infinity. This was from the previous slide that you saw where everything was on CPU 0 and CPU 1, 2, and 3. I didn't show 2 and 3, but CPU 2 and 3 weren't doing anything. Okay, so load can be a really good indicator if you're using that CPU affinity task set or IRQ balance to spread the load around those the available cores that you have on that instance. Okay. Monitoring and alerts. Hopefully, for those of you that are RightScale customers and are using the RightScale Dashboard, you're using them, right? The monitoring and alerting, despite what you've heard, I don't think it sucks. I think it's awesome. Is that I use it all the time, right? We use it to, eat our own dog food, drink our own champagne, or whatever the word may be, right? We're monitoring our servers and we're using our alert mechanisms to alert us when things are happening, right? All that I've really shown here as far as a screenshot is just some of the canned alerts that you get. You can create alerts for anything, right? And for those of you that are familiar with our custom collectd plugin mechanism, you can also create your own alerts, your own metrics that you're monitoring, and tie your own alerts into that, right? Look for little problems before they become big problems, right? You want to act on the initial emergence of that problem and not when it becomes something that's affecting your end users, okay? And as I mentioned before, as far as the over-greased wheel, if you will, look for underutilization as well, right? That's not as critical, but that's where you might be able to save money, right? And the point I make in the second bullet too is look for trends, right? Don't look for spikes and anomalies. Don't say if CPU goes above 80% for a minute, something freaky might have happened. It might have been, an anomaly, right? Look for trends. Look for things that happened over multiple minutes to see that, yes, these things really are issues. But also don't set those thresholds too high. Don't say, hey, look, if CPU is over 90% for 5 minutes. That's probably too late. Look if it's over 70% for 5 minutes, right? And see if you see things growing, that kind of stuff. Act conservatively, right? These servers are ephemeral, right? You can fire them up for an hour if you need to in an auto-scaling array and pay pennies, right? So it's a small price to pay to give you that sort of comfort, if you will. Okay, the next topic is HA and DR, a little bit about high availability and disaster recovery configurations. And when I take a look at customers' deployments, these are the kinds of things that I'm looking for to see, are they set up to absorb instances dying and or even potentially regions dying, okay? Some of the considerations, and like I said, there's another presentation where we go into much deeper detail, but this is sort of a summary of some of those. But avoid those single points of failure, right? If you have a single point of failure, you don't have HA, right? Basically by definition. If one thing can take you down, it's not a good place to be, all right? Use those availability zones, those AZs, to your benefit. spread the load, right? You have use multiple load balancers. Use your array across multiple availability zones. Put your master in one availability zone, your slave in another. Spread that around, okay? Granted, you're going to pay that penny a gigabyte for that inter AZ traffic, but again, hopefully that's a pretty small price to pay and something that will be lost in the noise of your provider's bill, okay? You want to replicate data across the availability zones, for example, the master-slave replication kind of concept. And you want to back up or you want to replicate that data across to another cloud or another region to give you some disaster recovery capabilities, okay? So that if that entire region was to go down, you would have the data that you need in that other cloud. One of the concepts we talk about, and I don't show it here necessarily, is a warm DR scenario. And that's where you have a slave that's running in another region, an entirely different region, and you're replicating your master in Cloud 1 to this slave in Cloud 2. And in theory, if things are going well and this entire region goes down, your RPO, your recovery point objective, could be darn close to zero, right? If it's been replicating, it's been keeping up, hey, it might take you a little while to get all this stuff fired up, but you haven't lost any data, okay? And that's probably the most common use case that we see folks as far as a multi-cloud or a hybrid cloud solution is using a disaster recovery, a warm DR. Have all the servers ready to go in the other environment, your backup or disaster recovery environment, with the exception of the slave, which is running, so that's the warm part of it. And if really bad things happen, promote that slave to master, fire up your other servers. If you're familiar with RightScale Dash, basically it is launch all, right? You can go ahead and launch all the servers with a few clicks of a button, if not one. Once everything's up and running and stitched together, point your DNS over and you're up and running, right? We've had customers do fire drill emergency sort of test runs and been able to get an RPO of basically zero and an RTO of less than an hour. And that's pretty good. And this is for production type websites, okay? Set up monitoring alerts. Again, I'm going to plug our monitoring alerts. Use them, right? Those capabilities are there. Use the monitoring, use the alerts to identify these problems before they become really big problems and automate the resolution to those problems, right? Again, as Joe was saying, stuff fails at 4 in the morning and that's when you're probably not at your best, right? You want to have a few buttons you can click that's going to solve the problem so you don't have to do any thinking or any manual work at that point. Availability zone distribution. That's the first thing that I always look at. And this is one of the examples where the guilty's names have been redacted. But you see here a server array where every single server in the array is running, again, small font, but it's running in EU West 1C. They have the entire array set to launch in that one particular availability zone. If EU West 1C goes down, they've lost everything, right? The EU currently has 3 availability zones. Use all 3 of those. If an AZ goes down, you've lost a third, right? That folks might not even notice, or maybe there'll be some performance degradation to your application, but it'll still keep running. If they lose EU West 1C here, they're out of luck, right? They're going to have to scramble to get everything back up and running. So how do you do that? For those who are familiar with the RightScale Dashboard, when you're creating your array and you're setting up all of your array policies and your configuration information, one of the things you can do is set up a weighted array, which is generally what we recommend. And as you see an example here in US East, there's 5 availability zones. So I've set it up so that, hey, I want to have 20%, I want to have 1/5 of my servers in each of these availability zones. So if something bad happens, I've lost 20% of my app tier, or whatever this tier is, most likely, infrastructure. I haven't lost everything, right? So we can't stress that enough. For the clouds that present this concept to you, absolutely take advantage of it. It can incredibly promote your HA. And for those that have multiple, 3, 4, 5 availability zones, again, your customers might not even notice, right? Or maybe it'll be just a slight performance degradation, okay? A little bit here on HA and DR, and this is more of a DR kind of concept. What you see here, and again, you can read it or not, but we have a database master and a database slave. They're both running in US East, but the master is in US East 1A and the slave is in US East 1D. So we're following our own best practices here, right? We've got a master in one availability zone, the slave in another availability zone. If we happen to lose the master's AZ, we can promote the slave. If we happen to lose the slave's AZ, we can fire up another slave and no one will even notice, right? But we also notice on the slide, so we have another slave, the DR, the Disaster Recovery Database slave. And this particular one is running in US West, right? So we're basically following our own best practices again. We have another slave in an entirely separate region, entirely separate cloud, replicating from that master and keeping as up to date as possible, right? So we have this disaster recovery, we've replicated that data to another region. But what we also have is we have our other servers that are involved in running this entire application, running in US West, and they're in this non-operational state. So this isn't costing me anything, right? They're ready to go. And if something bad happens, I can say click launch, right? They're ready to go, they're staged, they're all set up, but they're not costing me anything, right? And this is sort of one of the huge advantages, if you will, of the RightScale platform, right? If we lose our primary region, let's promote that slave to master. Let's click go on these two buttons, on these two servers when they're up and running, move my DNS over, and I'm good to go, okay? The next topic is security. And this is where I've seen this run the gamut when I've taken a look at customers' deployments. Some folks are super strict about this, which is great, and others have stuff, as you'll see in a second, that maybe isn't so great, all right? The first and foremost, obviously, is security groups. For those who are familiar with AWS, if the cloud you're on provides security groups, you should absolutely use them. They're an awesome thing, okay? Actually, before I move on to that, I thought I apologize, there was a pretty picture there too. But for those of you that are familiar with or not familiar with security groups, basically it gives you the ability to specify a range of IP addresses and a range of ports and say, hey, for these IP addresses, they are either allowed in or not allowed in, if you will. And the beauty is that you can add security groups to other security groups and create this nested concept. So you don't have to worry about setting all these policies on all these different security groups. You can basically create a security group and say, hey, all the servers here, I want to be able to talk to this one, or all the servers here, I want to be able to talk to these. So definitely take advantage of security groups. The cloud you're on provides that capability. For those that don't, we have built into the RightScale templates our firewall rules set, basically. And that's basically using IP tables at that VM level, right? So we're setting all the IP rules. What I've highlighted here is the do list rules. And this is the one that's, I can't, as an observer, I can't run this on our accounts. This is something you need to have different privileges to be able to run. But the point being is that you can usually take a look at your inputs. Even if you only have observer rights, you can basically take a look at the inputs and see if the IP tables, if the firewall rules have been enabled, and that should give you a feeling that, okay, at least these folks are taking advantage of this, right? But what I generally recommend is go ahead and run that script or run that recipe and take a look at the audit entry and see what the output is. And so what I've highlighted here is, here's an example where these folks have port 22, SSH open to the world, right? Probably not something that they want to do, okay? So take a look at your security group configuration, take a look at your IP tables configuration, and make sure that you have things open to who you, A, you know who they're open to, and B, that you really need them to be open to those particular servers or services, okay? A little bit on OS patching. We're currently on the version 13.3 release of our server template set. The upcoming release, which will be version 13.4, it's going to have recipes to do what you see here. So on Ubuntu, you'll be able to unfreeze the security repos, right? Ubuntu has the concept of sort of these named repos, if you will. You'll be able to unfreeze those security repos. And on CentOS, you'll be able to unfreeze essentially the upstream, the non-RightScale repos, the CentOS repos. And then you'll have another script to allow you to perform that security update. So you'll be able to basically say, hey, I want to just run the security patches on this particular instance or instances, right? Again, this is coming out in 13.4, which I believe is the May release. So this is coming out soon, okay? And this was a common request and something that we've been looking at internally as well. So this was driven not only from customer input, but also from our own operations team input. Best practices, sort of the last thing that I take a look at when I look at folks' deployment configurations is, are they following cloud and selfishly RightScale best practices, right? Again, this is to promote those operational efficiencies and to allow you to do automated recovery or crisis management type stuff in a non-manual fashion, right? We always recommend you have things automated and trigger them manually, right? Take a look and make sure that I know what's going on, or I know what's going on, and hey, I happen to have a script that takes care of this problem. Let me click go. So first thing, image bundling. We don't recommend it, right? We generally don't recommend it. And why don't we recommend it? Because it's the lack of flexibility. It's a very inflexible solution, right? If you have bundled up all of your software into your right image or AMI, which becomes a right image, whatever it may be, at that point you're locked into those particular versions. Hey, I've got PHP 5.2 on here and I really want PHP 5.3.6. Well, what do you got to do? You got to start from scratch, create a brand new server which has all the bits and pieces you want on it, and rebundle it, right? For those who are familiar with the RightScale platform and the server template methodology and the boot sequence in particular, hey, just start with this vanilla right image and use the server template in that boot sequence to install all the stuff you need. And if I need to swap out PHP 5.2, I just got to change one script. I don't have to do any new bundling, any of that kind of stuff, right? You also would need to, until recently, Amazon introduced the ability to move snapshots and also images from region to region. You used to have to do this in every region. You'd have to do this in a region and at least copy it to all the other regions that you may or may not be that you would be running it. Okay. And as I said, use the server templates to configure those servers at boot time. If you need to speed up that boot time, and we'll talk a little bit here in the last two cases about where we see it making sense perhaps, use EBS backed images, which boot a little quicker, but you pay additional for those because you're paying for the EBS storage for those every month. And it's rare where we see bundling as a recommended solution. And these are sort of the two cases that I've seen in the past where we kind of said, yeah, it does make sense for you guys to go ahead and bundle. Curiously, these are both and tend to be on the Windows-based images, right? That's where manual install of software may be required. You may have some MSI that just requires you to hit next, 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 and you can't find a way to automate around that. Okay, there's a good argument for go ahead and bundling that, right? Go ahead and install it once and then bundle. And the other time is if the boot time is unacceptably long, right? You have some dynamic event, you have some influx of traffic, and you're doing all the right things. You've got monitoring in place, you're conservatively scaling up, but it takes my server 35 minutes to boot. And by the time it's booted, that event is passed. I've missed that opportunity, right? In that case, then yes, it might make sense, probably does make sense to go ahead and bundle those particular instances to give you that faster boot time, okay? But like I said, with these two rare cases are where we see bundling making a lot of sense. We generally don't recommend it. And Amazon back in the day even used to recommend it, and now they don't. They've kind of gone towards this more use the vanilla AMI and configure it at boot time concept. Best practices, no single point of failure, like we talked about, right? A lot of these tie into the HA concept, but eliminate those single points of failure. When I take a look at folks' deployments, I'm always looking to see if they have a single RabbitMQ server, right? Or they have a single Redis server, right? Or, God forbid, they have a single MySQL server and they don't have a slave, those kinds of things. Always looking to make sure that I see some sort of, not just dual purpose, right? I have two servers or more doing the same thing, but they're spread across those availability zones, right? Distribute the servers in each tier across those AZs, right? Take advantage of that segregation of power and networking and everything that the cloud provider gives you. And then this last one, use deployments as application containers. Most folks do this, which is great, but I've seen a few customers that don't. And basically the point here is that they have an application that's spread across multiple deployments. They might have load balancers in one deployment and their app server array in another deployment and their database in a different one and their Sphinx servers in another one. And you take a look at this and you just can't get your head around which pieces are which, particularly if they haven't named things well, right? And so what we generally recommend is use those deployments, that single view and that single pane of glass, right? Use that single view to be able to see all the servers that are participating in whatever this application is, right? Use that deployment as a container around that application. So if I need to debug or do any sort of triage on this app, I got to go to one place. I don't got to worry about where all these other bits and pieces may be. Okay. We recommend you commit your server templates, and I see this is a very, very common violation of best practice, faux pas, whatever the right word may be, but for those who are familiar, you have the ability, once you've created a server template, to commit it and basically create a revision of it, right? And you can go ahead and you can update revisions and you can update server templates and create new revisions of it, right? But if you're running on the head version, as these folks here are, if someone makes a change to the server template, and a very common problem where we see this is in an array. Let's say you've got your PHP app server array, you've got your PHP server template, it's on a head version. I've got 10 servers running in my array. I go to the server template and I make some minor tweak to it, right? And now I do an autoscale and I add 2 more servers. And now I've got 12 and 2 of them are different than the other 10, right? And you go ahead and you have some user call up and say, hey, I'm seeing this weird problem. You can't reproduce it, right? Because it's only going to happen 2 times out of every 12 that you hit this thing, right? So you want these servers, sibling servers, to be identical. You want identical siblings. You don't want these little one-offs. And if you use head revisions, you can end out with these one-offs. So once you get a server template to a point where it's doing what you want it to do, commit it. Right? You can always, extra revisions don't cost you a thing in the RightScale Dash, right? So commit those templates and name them well, give a description to each one. So if you ever need to roll back to, hey, which one was I using for this particular version? Hey, there it is in the name. I can go ahead and roll back and change to use that particular revision. So again, I see this violation a lot and it can cause a lot of problems. A lot of these really hard to diagnose problems, which is the real issue. Use credentials for all sensitive inputs. Even with observer privileges, and again, I eliminated the names and some of the stuff here. This is a customer that I was taking a look at. I had only observer privileges. I didn't have admin or actor or anything like that. I was able to see their database password. right? Because they'd use it as a text input, right? RightScale has a concept of credentials, right? Use those credentials. Use a named credential. There should have been a credential called my database password or something like that. And all it would have shown me is what you see down there at the bottom. It's an example for the RightScale AWS access key. You'll see it says cred, it's a credential, and there's the name of the credential. And as an observer, that means nothing to me. I know you have one, but I don't know what it is, right? So use credentials for any sensitive inputs, anything that you don't want a casual observer to be able to see. Autoscaling. Obviously, many of our customers use RightScale for its autoscaling capabilities, but some customers don't necessarily use it in the right way. And what I mean by that is, let's say that your minimum, right? You can set an array minimum and array maximum. Let's say that your minimum is 2, and in the middle of the night, not many users are using your thing. So you've got 2 just to make sure you have redundancy, and they're pretty idle, right? Well, you should find out, what size do I need? I don't want to be running on a C2 8XL and have 2 of them running that is running at 1% utilization or something ridiculous. Those things are costing me $2.50 an hour or whatever it is, right? Find the right size, find the right building block, right? Maybe it's an M1 large you can get away with for a much cheaper price. Maybe you need a C1 for whatever reason. Maybe you need an M2, or in Rackspace you need an 8 gig server, or maybe you get away with a 2 gig server. Find the smallest sort of building block that will suffice for your needs, because in those scale down events when you're running at low capacity, you don't want to be paying that extra money again. Again, it goes into server utilization and cost optimization. So find the right building blocks and go ahead and drop them in an array, and let the array take care of the demand that you need. Don't let big servers take care of the demand that you need. And then automate all operations. Again, can't stress this enough, right? You shouldn't be making manual changes. If you're SSHing or RDPing in your instances and dinking around with config files, it's not a good thing, right? You're probably doing something wrong. The reason being is that if you reboot, that's lost, right? As soon as that instance goes away, that change has gone away. And if you didn't document it and know exactly what you did, you're not going to be able to recreate it. And what I say about automation is documentation. If you have that all scripted, right? If you have every single change that I do scripted, well, those scripts are my documentation. I can go ahead and look at what went into this server. Well, let me just look at every single one of these scripts, right? So that automation, the creation of those scripts and recipes, basically is self-documenting, right? So you know exactly how those servers are configured. Again, I can't stress enough, if you're SSHing or RDPing in and messing around with config files, and it's in a production environment, you probably should take another look at how you're doing things, okay? So, summary. Deployment sprawl, right? It happens. It happens to everybody. It happens to us, right? I mean, a lot of these examples I gave were from the accounts that I use every day, right? It can lead to cost and operational efficiencies, right? Just stuff grows organically, and we know that. You can find cost optimizations in a lot of places, right? It's not just server utilization. Like I said, that dirty laundry concept, right? There's probably a lot of stuff in your accounts that you probably don't need, and they're costing you money. It might be significant amounts of money as well. Find the right resource. Find the right size resource. Again, like I said, don't assume that, hey, I'm going to throw the biggest piece of virtual hardware at it that I can. You probably don't need to do that, right? HA, you should design it in from the start. Always think about HA. Use those availability zones. Use multiple servers at each tier. Eliminate those single points of failure, okay? Disaster recovery, it can be affordable. People think it's super expensive, right? And it can be, depending on how you set up, but it can also be pretty affordable, right? That warm DR scenario we talked about, one slave in one server with its attached storage running in another cloud. That's all you're paying, and the bandwidth between, granted. But that's all you're paying for that disaster recovery. That's, again, it's insurance, right? How much money are you willing to spend for something you hope doesn't happen? So you always got to play that trade-off, okay? Security, only open up to the world or to even internally the things that you need opened up. So take a close look at your security groups and your IP tables set up and make sure that it makes sense. If you don't know why a rule is there, find out why that rule is there, right? Because if you don't, and it's a potential place for an exploit, someone's going to find it. And as I said, best practices tend to promote those operational efficiencies, allow you to take corrective action in a automated fashion when you trigger it manually. Hey, I want to make sure I know what's going on. I do know what's going on. Great. I have automation in place to take care of this. All I have to do is click. I don't have to go ahead and scramble to do this, right? Because again, these things don't fail when you want them. Well, you never want them to fail. They never fail at an opportune time. Always at inopportune times, right? So that's pretty much everything I had. I don't know if folks have any questions. If you do, I'd be glad to take them. And if not, I'll be around afterwards if folks have anything too. Yep. Oh, Kara. Oh, thank you, Kara. Got our microphone runner.
Question about the durability of security credentials. When you pass those credentials to the servers, do you write them, or do you just keep them in the memory? And if you keep them wherever they're kept, are they scrubbed after they're not needed anymore?
They are not necessarily scrubbed after they're needed anymore. So again, you should be able to, well, if they're inputs to the script, they're passed into that script as an input. They're not necessarily laid down on the instance, right?
So they do get to the disk?
They do not get to the disk, no.
Okay.
No, they do not. If you're using like SSH keys and things like that to allow you to SSH from one to the other, then we're putting those keys on. But no, those credentials are just used as inputs to the scripts, and they don't find their way onto those instances. And if you take a look at the audit entries, once you've run one of those things, you'll see, I don't have an example, but it'll say like cred blah. It won't give you the value of it, things like that. So if someone has observer access, they won't be able to see what that was as well. So it's not on the instance, and it's not in our audit entries either.
Well, my concern was more in terms of an attacker compromising a machine and then using credentials. You know, if he can pull credentials from memory or disk, then he can obviously go ahead and compromise whatever else those credentials have access to.
Not on disk, but as far as memory is concerned, that'd be a little bit of a different scenario, right? I don't know if we can necessarily control that. You probably use some sort of map tools or something like that to scrub things when you're done. But as far as them hitting the disk, no, they won't be hitting the disk.
At least nullify them at the end of this, basically. So when the script has run its course, at least overwrite them?
Well, I'm saying they're not on disk, so there's nothing to overwrite.
No, I meant in the memory. Even as environment variables.
No, we don't do that. We're not going to be messing with your instance's memory, right? That's up to you to decide, right? That's the last thing we want to be doing is going ahead and mucking around with your guys' memory. So if that's something that's of concern to you guys, you can go ahead and take care of that on your own. But that's not something we would or should be doing, right? We should not be modifying your memory on your instances.
I understand that. I guess my question was, so the script itself, you're going to write to the disk, write scripts, are going to get to the disk. The variables, you're going to pass in, the credentials, you're going to pass as variables, and they will not get to the disk, but they're in memory. Now, when you have executed that script, is it possible to have a functionality to actually now go back and scrub those in memory, overwrite those with those variables with zeros or what have you?
Not feasibly, and that's, again, not something that we would want to be doing for you. You can write automation to do that yourself. You're absolutely welcome to, but again, I don't think, I probably speak for most people, want us going in and modifying your memory in any way, shape, or form. What if we had some sort of issue or problem with that, right? So you can do it yourself. We're not going to do that for you. That's the short version answer. Anybody else? Thank you, Kara.
Yeah, some of the cost-saving tuning that you were showing earlier makes a lot of sense. Being able to sort it by inactive status, last time accessed. Is there any way to automate some of that info into, say, reports? I could really imagine that those would be the kind of thing we'd want to configure a report for, and then maybe once a week or so have that emailed to some people. Here's all of the EBS volumes that haven't been accessed for over 9 months, meet this criteria. Here's their tag for cost center, et cetera.
Yep. And actually, CFR, I was going to look for some product managers in the house. Hassan, do you happen to know from Ronnie if the enterprise manager can accomplish that currently? I know you can do it with the API. My answer is yes, you can do that with the API, but that's a little bit clunkier than most people want. We have an enterprise manager tool that'll allow you to do a lot of reporting on this level. Do you happen to know if it can give you information on like EBS volumes and EBS snapshots and stuff like that? Not currently? Yep. Got it. Okay. Okay, so the answer is not currently, but through the API, yes, you can get access to that. You can get full access to all of your EBS snapshots and sort them by whatever fields you may or may not want, and EBS volumes as well.
And that's the product manager?
No, sorry. That's Hassan. He's our head guru on Plan for Cloud, but he's been giving presentations with the appropriate product manager who would have been Ronnie, but Ronnie wasn't here, so I leaned on him instead. So if you find Ronnie Redjev, he'll be the guy that would be able to give you that information.
I'm usually loud enough. So in Plan for Cloud, you can currently import a snapshot of all your EBS, S3, and snapshots into Plan for Cloud if you're looking at different kind of cost perspectives to see where your costs are actually going within the storage and how significant those storage costs are. So it's a tool called Plan for Cloud, and it's completely free. So you can jump on there and enter your credentials, and it'll import a snapshot of what you're using currently and show you the information. Give me a shout if you want a demo afterwards or anything like that.
Actually, I was just responding to your question. I didn't have a question. So you wanted to look at some sort of reporting on how your usage is on the EBSs or instances. If you're talking about Amazon, in Amazon, you can set up alerts. And you can see if your instance hasn't been used to a certain percentage. You can see that in your alert page. Also for the EBSs, how many EBSs you're running, or you're close to your limit of EBSs, you can see that as an alert. We use that page a lot, but it would be nice to get that in an email when you reach that when you reach that limit. I think that's a feature that Amazon could provide us. That would be great.
Yeah. And that would be a great, sorry to interrupt, that'd be a great.
So yes, there are alerts in Amazon which you can set up and you can watch them.
Can you do that for aging of snapshots? I haven't been able to see any way to do that. Hey, I've got these snapshots that are this old, that kind of thing, right? And that's where a lot of this cruft is. It's not necessarily how I appreciate that. It's not necessarily how many EBS volumes I have. It's how many I have that I haven't used in X amount of time, that kind of thing, right?
Yeah, so we have had that scenario as well. We actually set up EBSs to be deleted, properties delete on termination. So for example, if I've attached an EBS and if I've removed it, I would want to delete it. And at some points, it doesn't quite happen. So 10% of the time, your EBS may not delete. And I found that those are the cases that remain for months. Yep. Your EBS is still lying around. And that we do monitor via the API call, to see whether there's an EBS lying around for that long. Right.
And the point is well taken, is that is a great feature for our enterprise manager. So I'll mention it to Ronnie if you don't see Ronnie. Also sorry, this was probably mentioned in a couple of these breakout sessions as well, and I should mention this also. At feedback.rightscale.com, if you're not familiar with it, that's sort of our, hey, give us your ideas and what you'd like to see. Please feel free to enter that and any others as well, because I have my wish list, right, and I have a little bit of pull. You guys that are paying us money have a lot more pull than I do, so please throw those ideas out there, and that's the more sticks there are in the stack, the quicker we'll break that camel's back. So, yeah.
I have a question regarding auto-scaling. In the array, all the instances is the same size, right?
Correct.
So when you say off the peak hour, you kill all the instances, and can you select what to keep or what not to keep?
Which of those instances?
Yeah.
No, not currently. Currently, the way the auto-scaling down works, so the answer is not currently, but. So I'll get to the but. Not currently. The way that it works is auto-scaling will terminate the oldest instances, if you will. So you'll have the newest, most fresh ones that'll continue to run. When our Cloudflow automation comes out, and I think Ryan or somebody's giving a demo on this later today, when our Cloudflow automation comes out, you'll have much more granular control over your arrays. You'll be able to say exactly which ones you want to scale up, which ones you want to scale down, which ones you want to keep, that kind of thing. So not currently, but coming.
A continued question is, when you scale down, and then can you further resize the machine? Say if you have an extra large machine, and then during the off-peak hour, you not only you want to downsize, you want to also
No. An array is associated with a server template and an instance size. So you can't change that, and that's why I was saying one of the recommended best practices is find that smallest building block that makes sense, right? Instead of running 2 of these big ones, maybe run 4 at the small, and go ahead and grow accordingly. And I think if you do the math, a lot of times it's actually cheaper to add more smaller instances than a few larger ones.
So you cannot further resize the
instance. Not during a scale down event. Nope. An array is tied to a server template and an instance size.
Okay, thank you.
Yep. Anybody else? All right, cool. Well, I want to thank you all very much for your time. Appreciate it, and hope you enjoy the rest of the day.